Hey, Sheikh Moshad, if I'm not uh, wrong. Sheikh Moshad. Okay, guys, so let me start without any further wait. Sorry for delay, but let's start. So we are going to start this CCNP. So I will little bit talk about the brief history about the CCNP. Then probably you guys will understand in better way how this is going to happen, what is the roadmap, and why it is very useful nowadays, CCNP, and what is the market demand as well. I know you guys are aware about that, but we'll discuss a little bit some certification programs as well. So probably it is going to be helpful for the everyone. So very first thing, let me first share my screen and then we'll discuss about the certifications, right? Why purposefully I'm starting this CCNP NRC? I know like some people are waiting for the ENCOR, but little bit we have to do the comparative analysis, right? What inside the ENCOR, what is in NRC, and which is going to be more useful. So if someone is planning for the CCI exam, right? And they want to just go for the certification for the initial stage, then it's very important to complete the ENCOR. And who already done the ENCOR, that is very good. But if you've not done the ENCOR and you're planning for the even CCIE certifications, where that, hold on, then probably it is going to be very difficult for you. Yeah, this one, I was just searching. So you guys see here, we have the CCNA, right? We have the CCNP professionals. And in CCNP professionals, we have the CCNP collaborations, we have the CCNP enterprise, we have the CCNP security, and also we have the CCNP cyber security. And then we have the expert level of certifications. Then it is going to be CCI. So if someone is planning to go for the CCI certifications, okay, it is very important you have to complete the CCNP Enterprise, especially in CCNP Enterprise, you have to, right, you have to do this in core, right? This is need to be done in core. And then in core is just, it's all about your fundamental of the networking, means next generation networking fundamentals, means you're going to learn about the SDN technology, you're going to learn about that SD-WAN technology, means overview. It's not deeper side. You're going to learn about the VXLAN, you're going to learn about the QoS, you're going to learn about the wireless, everything. But eventually, you're going to get the basic infrastructure knowledge about the CCNP. And NRC is, it's going to be give the advanced routing concept. If you go and try to understand a little bit course content, let me open that. Let me open the course content as well. So you guys will get a little bit more understanding. Give me 1 second. Okay. So if I go for the in-core, you can see it is all about the architecture, virtualization, infrastructure, network assurance, security, and automations. This all topic we are going to cover, right? And this, more about this, you're going to get the theoretical understanding, means you're going to understand about the architectures, understanding, you're going to understand about the FHRP, SSO, right? You're going to understand about the network design, right? And you're going to learn about the wireless, right? You're going to learn about the like how we are going to design the SD-WAN understanding, SDXS understanding, traditional campus network understanding. And also we are going to discuss about that, QS, policy map, prefab. So this all more about the theoretical, little bit the, some practical concept also going to do that. Then the virtualizations, understand the what is the hypervisors, virtual switching. Then we have to understand the VRF, GRE, IPsec tunneling concept, LIPS and VXLAN concept you're going to understand. Also going to understand layer 2, layer 3 infrastructure concepts. And at the same time, we are going to understand the OSPF configurations, like how it is going to done, BGP. But these are the basic things, not very advanced for the routing point of view. But and even the wireless, we have the more details wireless here, IP services, NAT pad, and also network assurance, how the network assurance is going to be look like. And at the same time, you can see we have the security ACLs and COP policy, and then we have the authentication method, we have the some theoretical concepts as well, and also we have some EMS scripting and automations, Python, JSON, how it is going to look like. So this is more about the theoretical concept. Means you are going to get deep understanding about the 360 view of the networking. But if you want to become the expertise, then you have to do the specialized certifications. Let's you want to become the champion of the routing. So for you, you have to start learning with the CCNP NRC. That's where we are starting today. In this CCNP NRC, we are going to get in-depth knowledge of layer 3 technologies, VPN technologies. Means especially we are going to talk about the BGP. We are going to talk deep dive of the like EIGRP. We are going to do the deep dive of the OSPF. We are going to do deep dive of the uh, like IPv6, right? And also we are going to understand the MPLS. MPLS in this, you don't have to do much. It's only theoretically. But if you guys want, I will cover MPLS. There's no problem. But yes, IPv6 is going to be there completely. It's the configuration. So if you're coming from the background like CCNA we have done, right? You already have the good understanding of the IPv6 because theoretically in new CCNA, if you go in the syllabus, they are just covering the IPv6. If you go in the CCNA syllabus, right? So IPv6 is a part of the CCNA syllabus only. Means everything like you're going to understand. Let me discuss about that. Let me show you guys. Where it was. So see, here is the IPv6 static routing you're going to get here. And also they have the, where was the concept? Yeah, might be in this one. See here. So you have to understand what is the unicast address, what is the multicast address, what is the modify UI64, what is the link local address, what is the global address, what is the like unique local address. So these all theoretically you have to learn in the CCNA level. This is the IPv6, but practically how it is going to be configured. If I go in my lab scenario, so we will do in very depth kind of the redistribution and learning. So let me show you. It is going to be part of the CCNP. And see, so in this advanced lab, we are going to configure this complete IPv6 OSPF based configurations. We are going to do this IPv6 BGP based configuration. We are going to do the EIGRP domain based configurations. We are going to discuss about the EIGRP, how it is going to redistribute the route from the EIGRP to BGP, further BGP to OSPF, OSPF to BGP. And even if I want to apply some filtering, then how it is possible. So these all detailed based learning, we're going to do that in IPv6. So you don't have to worry. Even we have the any kind of the confusion about that. What is the link local IP address, how it is going to use. I will cover those things also. Don't have to worry. But the idea is you should become the champion of the networking in terms of especially for the routing, right? And you also going to get VRF configuration for VRF Lite and MPBGP configuration as well. Why MPBGP? Although it's not part of the syllabus for the CCNP, to be honest, if you go for the course content, you're not going to find the MPLS. But I love to cover that because I want you should not have the incomplete knowledge. So if I go a little bit down in my routing lab, you'll see here, this is one of the biggest topology. You guys have to play around it. Means OSPF configuration, we have to deploy the MPBGP where we have to create the multiple P. Inter P, we have to learn the VRF. Means how to export route, how to import route, how to build the core, and how we can build the route reflector, right? And based on that, how we can enable the OSPF and we can create the LDP, and we have to create the LSR for that particular PEC connectivity and all configuration we are going to cover. So these all are going to part of the course content. So you are going to get that BGP very deep detailed understanding, even the path manipulations. Step by step, all path manipulation is going to cover what is the peer group and attribute for the base path selections, route reflector, including the multiple route reflector, configuration, dynamic peer, means everything I will cover, inbound, outbound policy, filtering, how it is going to happen. And see, it's for the MPLS, it's just talking about the describe, but don't worry, I will cover these all things. And rest is going to be your DM This is going to be something where you are going to get how the phase 1 tunnel is going to be created for DM how the phase 2 tunnel is going to get created for DM how basically we can do the phase 3 tunnel configuration. Basically, what was the problem with the our static IPsec tunnel, dynamic IPsec tunnel, how this DMVPN is going to solve that kind of the, how we can build the NHRP, underlay connectivity, overlay connectivity, that we are going to cover under DMVPN. So you guys feel free to ask anything if you like, feel like if you're not getting, not understanding during the session. So I'll make sure that is going to be covered at all. Okay. Rest. Rest are going to be like TechX, AAA, IPv6. That all we are going to cover. Extended links, right? This is going to be troubleshooting, client BTY console, DSCP client, iOS. Means a small topic we have that definitely it is going to be part of discussion. But in NRC, you just have to more focus about that routing part. That's it. Means in end of the NRC, you should have these skill set. Nothing more than that. You should be champion of the EIGRP, right? You should be champion of the OSPF, and you should be champion of the BGP, advanced BGP. You should be very good in the DMVPN as per the syllabus. Bonus would be the MPLS, deep dive. Okay. So some small topic we are not going to touch, unnecessary topic we are not going to touch. If you guys want to touch as per the exact syllabus, some small topic, probably we can skip this one, but choice is yours. Okay, I'm completely fine. But my suggestions, we should include this all things. And in top that, you should know IPv6. Not only configuration on OSPF, how we can configure the IPv6, on EIGRP, how we can configure the IPv6, and BGP, how we can configure the IPv6, and how we can redo redistribution, how we can do the redistribution between these all protocols. That we all are going to be covered. Okay, it's clear to everyone. Any doubt, please let me know. Jason, clear?
Clear. Yes, sir.
Sabir, you okay?
Thank you.
Banu?
Yes, clear, clear.
Okay. So let's start, okay, without wasting our time. So very first thing, when we start the routing, first of all, we have to understand what is the routing. Anyone want to say something? What is routing? Why basically need a routing? Any
To,
idea? Sabir?
to move the packet from one network to another network, right?
Okay. So you're saying routing needed to move the packet from one network to another network, right?
Yes.
Yeah, that's correct. Any other kind of the definitions you want to give?
Routing is basically to find the best path from one place to another, from our source to destination.
That's good, right? So find the packet to send means find the best path to send a packet from one place to another place, right? Okay, so that's good, right? So let me open one of the document and we'll refer that also. So might be we have seen the GPS, right? GPS is also going to be just help us to reach from one location to another locations, right? That's why there is examples routing is a GPS of your network data. Means if you want to reach from one source to another destinations, you required some kind of guidance, some set of the rules. That's the routing. So if you want to basically send some packet from one location to another locations, you have some sort of the routing tables. That routing table basically going to be contain multiple set of the prefix informations, and that prefix informations is going to help you how to route traffic from the best path. Means even go in the GPS, right? And if I go in the Google map and let's suppose I want to set my map for the, let's suppose, let me go in my Google map. Where is it? This is a map, okay? I want to go in the airport, okay? So if I go for the airport, so you guys will see in this airport, probably, see, we have the multiple path. If I'm starting here, I can choose this path, I can choose this path, right? This path, this path. So Google Map having the entire path informations. That's the same thing routing is going to work. Means when you're going to use the routing is going to contain entire your path information by leveraging the routing protocols. It could be your static routing, it could be your dynamic routing. So static routing could be manually you have to define the whole path. Dynamic routing that is going to help to learn the path from different kind of the networks or different kind of the next stops. And based on that, the brain is going to contain some set of the data, and that data is going to help to decide which path is better to reach from one network to another network. That's why routing is a process to select the best path from one source to another destination, which is my best path is going to be take lesser time and without any kind of the latency, without any kind of the data loss, or without any kind of the hiccups during the transitions. And that's why routing is going to help to take a right path decisions, right? If I talk about the more about the routing can be further classified into various way. Means we already know this routing has the two kind of the definition. One is the static routing and another is a dynamic routing. In a static routing, basically manually you have to define everything. Means let's suppose this is the R1, this is the R2, and this is my R3. This is my R4. If you have the requirement, just go one by one to reach 4.4.4.4/32. Trust me, static routing is one of the complex routing process in compared to dynamic routing. Why? Because you always have to think whenever define the routings, you always have to think about the forward directions and also you have to think about the reverse directions. And most of the engineers going to make the mistake in this decision process. Why I'm going to tell you? Because they think if I'm receiving this route, that means my routing is fine. But that's partially true. If you're receiving that route, it doesn't mean your routing is fine. You always have to make sure your hope by hope, path by path, your routing is going to be clear. Means you're sending some traffic from this direction to reach to this direction. That means you also make sure you have the return path. It should not like you just going to tell the one-way traffic should reach to destination and destination don't know how to revert back to you, right? And who is my sender? So how I can reply? So that's why the forward and reverse routing is always going to create a problems for the engineers while doing a troubleshooting. So whenever you start doing a troubleshooting, you make a rule, and the rule should be I need to verify what is my forwarding path and what is my reverse path. If you have the command on these two concepts, you are going to be champion of the routing. Every routers must know how and where I need to forward the packet. Take an example, why it's very important. This is my R1, okay? This is my R2. This is my R3. 3 networks. Let's suppose I'm using the IP here 10.10.10.1. IP here 10.10.10.2. Here I'm going to use 20.20.20.2. Here 20.20.20.3. Or okay, take it. Now I'll add one more router here. R4. This is going to be my, let's suppose 30.30.30.1. This is going to be 30.30.30.2. So if we have the requirement, I have to send a packet from 1.1/32 loop back to 4.4.4.4/32 loop back. Then how my static routing decision is going to happen? You have to tell on this router, if you want to go on this destination, first you have to put one of the static route here. Means you have to go here and 1.1.1.1./32. Next stop should be your R2. Then again go on R2. R2 again you put the same route /32 and you will tell next stop should be your R3. R3 again go and tell this 1.1.1. and /32. Your next stop should be R4. So your packet is going to be forwarded. Means this is the forward directions. So your packet will be forwarded from R4, means basically R1 to R4. But when the packet is going to be reached here, so in first place, when the packet is going to be created here, this packet having the source IP address, this packet having a destination IP address. What is my source IP address? In this case, if I'm not putting any source, then my source is going to be 10.10.10.1. Destination is going to be 1. Sorry, my bad. Destination is going to my 4.4.4.4. So this is my destination IP address. So very first time when this router is here, it will routing always check the destination, never check the source. Means when the first time user want to go in any destination, router will check not source, it will check destination. So it will check how to go my 4 network. I make some mistake here, my bad. Actually, this should be 4.4. My bad. I really apologize for that. This network should be 4.4.4. Okay. This is the 4.4.4, not 1.1.1. Okay. Because I'm reaching from the 1 to 4.4.4. Okay. So this is 4.4.4.4. Then it is going to be there. So my network static routing is going to be 4.4.4, 4.4.4, the R2, R3, and R4. Now the packet will reach on the R4. Okay. Once the R4 will receive this packet, your packet is going to be reversed. Means whatever you have the source IP address, your packet is going to be changed. Whatever your source IP address is going to be there, it's going to become a destination IP address, and destination is going to become source IP address. So take an example. You initiate a packet from 10.10.1, 10.10.10.1. Source you are going to take is a 4.4.4.4. So for reverse point of view, means if you think in this point of view, reverse routing, this routing is going to be managed. This routing is going to manage in such a way where my traffic is going to come. Then it will look for my 10.10 subnets. Do I have the route for this router? If the answer is yes, then it will forward to next hop. If no, then packet is going to be dropped. So you always have to put the forward and reverse route. So R4 have the route means 10.10.10.0/24 subnet. Next hop should be the R3. Then again R3 will check. Do have 10 subnet route? If not, then packet will drop. Then again this will have the this subnet. Next hop should be R2. Then R2 again should have the 10.10.10.0/24, and then it is going to be next hop. So in short, if you are going to define the static routing, you always have to make sure you have the source and destination route information. If it is not available, that means you are not going to make your routing decision correctly. The somewhere in the path, your packet must be going to be dropped. That's the static routing, where you have to define each and everything statically, manually. All right. So if I just change this behavior with dynamic routing, then probably you don't have to do that much effort. So it is going to be learn automatically for your source and destination, but it will add some other complexity. But a static is going to be add complexity of the network administrator to add more and more routes in every devices. And if you're going to miss anything in any devices, any incorrect decisions is going to break down your network. So routing is a network communication media. Without routing, your device from one network to another network is not going to be communicate. And routing can be achieved. And what is one network? One network is any subnet. Means network is what? Means this is the 10.10.10.0/24. This is the one network. And if I want to talk 20.20.20.0/24, this is the another network. So if I want to make the reachability between these two networks, then I need a router, the L3 device, not only router, L3 device. This L3 device could be your router, could be your L3 switch, could be your firewalls. Nowadays, all firewalls support the L3. So they have the capability to make the routings decisions between the two different network. And every packets means routing must be happen with the help of the L3 devices so that two networks can communicate to each other. And every router must know how to forward the packet, how to forward the packet. Which address? Destination address. They never check source address. Whenever you do the routing always work by default. I'm just emphasizing it because people always confuse. Routing always check destination address. Never source. Unless you're using the policy based routing. In PBR, you can use the where you can source based also routing is possible. But in normal routing, always happen for your destination. Depend, if you're going for the forward, then it will check your destination. If reverse, then your source is going to be become your destination. Only direction is going to be changed. Okay. Then it is going to be become the destinations. Now we understand static routing is eventually you have to do everything manually. Means whenever we talk about the static routing, you have to configure everything manually. Means you have the multiple thousands of the router, you have to do all router configuration manually. And trust me, it is going to be a very complex scenario, very troublesome for the network engineers. Static routing. It's okay for the small organizations, but if you go for the larger organization, we have the thousands of network, 500 of networks, it's not scalable. So what is the solution for that? How we can scale that problem? So it means how we can solve this problem. So we have the dynamic routing. Dynamic routing is a process where you just have to enable the routing. This enable the routing based on the interface, right? Or based on the global commands. This dynamic routing can be enabled sometime for the interface level, sometime in the global configuration. Global configuration. So you can enable anywhere. The end goal, whenever you enable the dynamic routing, the end goal, it will automatically exchange the route informations. Means you don't have to do manual configurations. That's the beauty of the dynamic routing. Means whenever you just enable, even on the interface level, I will show you later how it is going to happen. And even the global means by using the network command, router BGP, router OSPF, router EIGRP. Interface means you are going on the interface, and interface you can just enabling the EIGRP configuration. You are going to enable the BGP config, not BGP, OSPF configurations. That is going to be. So this will solve the network administration, means administrator basically work. You don't have to always do everything manually. Okay, you just have to enable on somewhere in the global level, and it is going to be just sort out your problem. So if I talk about the dynamic routing tables, so in dynamic routing table means not routing table, dynamic routing. In dynamic routing, we have the EIGRP, we have the OSPF, we have the BGP. And also we have the MPLS even going to be part of the SDWAN, and then ISIS. ISIS is not part of the syllabus, but this all are going to be, and even you can talk about the RIP version 1 and version 2. This is also not part of the syllabus. This is the old protocol. So this is basically the overall protocol where we have to use, and this all protocol is going to help in terms of the all kind of the communications. Okay, so dynamic is basically going to be helpful in term of the, if you want to do the get auto update of the routing tables. If you have the very large network, means the routing table is automatically update, means incremental update, auto update, and this is going to be scalable. This is going to scale your large network routing table, and it having the very faster convergence. It's having the very kind of the less administrative work for the users who is just doing the routings. Means you don't have to do a lot of kind of the configurations. And if I talk about the disadvantages, so for the dynamic routing as such, we not have any disadvantages, but the engineer who is going to do the configuration for the dynamic routing, they should have the very good knowledge about the protocols. And definitely if it is going to be used for the day-to-day configurations, and router, if you're going to use the static, they don't have to think much. Everything is put in the brain, how and where to work. But in dynamic, they have to learn. So they are going to increase your processing capacity. They're going to be used for the any kind of the RAM processing. This is going to be used. All right. Now we understand the static routing versus dynamic routing. Any questions, guys? Any doubt? The static routing versus dynamic routing till now? You can go here and you just do a little bit research on your Google as well. So you can find some good definitions. So you can see static routing manually configured, fixed path, suitable for the small, unchanging network, while dynamic routing is for the automatic protocol, adapt network changes, making the ideal large complex. The same thing I explained in my language. And the static routing configuration, network size, path, dynamic routing configuration, like we can use the BGP, OSPF, EIGRP, network size, path control. So we'll talk more about that. But in short, we have this definition about the routing protocols. Any question till here, or we are good till here? Let me know, guys, if any questions.
All good, sir. Thank you.
Okay. Now, one more question is going to be asked, always for the interview. And I want to check with you all, right? There is a concept which is known as the routing protocol versus routed protocol. Do you guys know? Do you guys know what is difference between this routing protocol versus routed protocol? Any idea? What is difference between this routing protocol versus routed protocol?
So routing protocol is what we have learned. They find the path basically, how to reach from one point to another point, and the best path. But the router protocol is one which carries your data. For example, IP. So IPv4 data.
Okay, so any example routing protocols?
EIGRP, OSPF, BGP, RIP,
Yes.
ISS,
Hmm.
and the routed protocol will be the best example is IP, and there are also other, but I don't have in my mind.
Okay, no problem.
Sorry
Good,
for
good
that.
answer. Good answer. And BGP, etc. And routed protocol, we favorite IP, right? IPX, and we have the Apple talk protocols. IP considered is going to be IPv4 and IPv6. So what is the routing protocol? So basically we discuss about determining the best path. Like where Jishan mentioned that it's going to be determining the best path, how basically we can reach from one source to another destinations. Means logical path, it is going to be tell the router how you can reach. So only it is going to tell how you can reach. Take an example of this particular Google map. So let me go on the Google map again. So you guys can correlate the definitions. Airport. So if I go here and let me find my on location. Okay. So this is my GPS. GPS is saying that this is the path. You can go from this location to airport. Okay. This is the path. You can take this path also. Okay. This is also. So GPS is acting as your routing protocol. It is guiding you how to reach from one path to another, means how to reach from one source to another destination. So GPS is might be your OSPF database, your EIGRP topology table, your BGP routing tables. So this is going to helping you to how you can reach to destinations. But does this carry your actual data? The answer is no. Means let's suppose I want to go from here to here, my home to airport, your location to the airport. This is the airport, okay, aviation center. So it is telling me you can choose this path, but actually how I can go? I need to use my car, might be the public transport, might be the bike, right? Or might be any other media. So the car, let's take another car. Car is actually who carry me from here to here. So this car is going to act as a routed protocol. Make sense? The car, which is just helping me to carry from one source to another destination. One is showing my directions, how I can go. But who is carrying actually myself, my luggage and all? That is my car, public transport, bike, or might be taxi. That's the routed protocol. So routed protocol is a protocol who actually carry your traffic, who actually carry your data. Routing protocol is a protocol who is going to give you the idea how and where you can just send the packet from one source to another destination. Clear, Sabir, to you? Bhanu, it's clear to both of you guys?
Yes, clear.
Yes,
No
sir.
doubt, right? So sometime it is going to be very interview-based questions. What is the routing protocol and what is the routed protocol? Okay. Now let's talk about few more things about that, because before we build to the our actual routing decision and configuration, we have to build our solid base. Now it is going to ask what is difference between the fib versus rib. Any idea? The fib is going to be known as the forwarding information base. And rib is going to be known as the routing information base. What is difference between these two? Any idea? Jishan, Shabir, Vanu. What is a rib? What is a fib? Come on, guys.
So rib is actually where, yeah, please go on.
If we provide the next hop details,
Which one, rib or fib, Vanu?
so fib
Fib is going to provide the next stop detail. Okay. And what is a rib?
fib is a routing information. I carry the routing table.
Okay. Good try, but if I want to understand, yes, Jason, you can go. Then I'll conclude. Okay. Don't worry.
So routing information table is actually which carry all the routes.
Okay.
So it
Routing
carry
information base
all
which
information,
all possible
all
route.
routes, all possible route, exactly, including best route and non-best routes, every route. But the forwarding will only take the best route from that routing table.
Very nice. Forwarding is only collection of the
Best routes. And when we see the routing table, so it is actually the fib, which is consisting of the routes which the router will send the data through.
Yeah, that's very nice. Thank you so much, Jason. Very precise
Welcome.
answer. So RIB is basically routing information base, right? RIB is routing information base and FIB is forwarding information base. So if I talk about the RIB is just what Jason mentioned, that all possible route to reach the destination. Take an example. Let me tell one of the example. This is my R1, right? This is connected with the R2. This is connected with the R3. This is connected with the R5. This is connected with the R7. This is the R8. This is the R9. Okay. This all connected with the R10. Okay. I just use one prefix. Take an example. There is a prefix that is the 10 dot 10 dot 10 dot 10. Hold on. This is the prefix 10 dot 10 dot 10 dot 10. Okay, /32. You can take an example. Now this path I'm running the EBGP, EBGP. This path I'm running the EIGRP. This path I'm running the OSPF. Now R1 will build the two table. One is going to be your RIB table and one is going to be your FIB table. Now, if I just go and define my RIB table, so I'm just giving the example. This 10.10 10/32 is going to be learned via the BGP. That's one route. Okay. This is going to be 10.10.10.10/32. This is going to run by the EIGRP. This is going to be 10.10.10.10/32. This is going to be an OSPF. Which one is going to be in the fifth table? Which route? Any idea? The same destination, I have 3 copy.
BGP.
And why, Jishan? Why it's BGP?
Because it's the best route according to the
AD
admin
value.
distance.
Yeah,
It has 20 AD value.
lowest AD value, yes.
AD is 20. And what is the AD value of the EIGRP?
9.
90 and 110.
Okay, so this is going to be OSPF. This is going to be EIGRP. And this is going to my EBGP. Okay, so now we understand based on the AD value, it is going to be select the base route, and based on that, it is going to be installed in the fifth table. So fifth table, in RIP table, we have the all possible route, but in the fifth table, we only select means all possible route, but in fifth table only we select the best route. And best route selection criteria could be based on the AD value. That is the one thing. And what is the other methods? Anyone know? So this is going to be 10.10.10/32 and via the BGP. Let's take an example to explore another method. Now, if hold on, let me make some different logic here. Now let's take an example. If I'm going to be advertise the prefix in BGP, I'm going to advertise the prefix 10.10.10.0/25. Okay, and from this way I'm going to advertise. From this way I'm going to advertise from EIGRP 10.10.10.0/24. And from the OSPF, I'm going to advertise like 10.10.10.0/26. So now in my RIP tables, in RIP table, we still going to receive the prefix 10.10.10.0/25. And for the EIGRP, it is going to be 10.10.10.0/24. And OSPF is going to be 10.10.10.0/26. Now you guys tell me which one is going to install in the fifth table now. It's going to be same. AD value is going to be lower for the BGP. What do you guys think? Which one is going to install now? Jishan, Sabir?
I think the OSPF one.
And why this
Because
time here? Because AD value just tell BGP is higher.
because it will check the closest match according to the subnet mask. I think it will work OSPF.
Sabir, you agree or you hearing very first time this one? Banu, what do your logic say?
Matrix, right? It will work.
Matrix is still AD, right?
Yeah.
Because Matrix is three different protocol, no? So Matrix is not going to come in the considerations.
Yes.
So AD should be tiebreaker or something else should be tiebreaker, or might be just in word saying that the prefix length, right? Jason, you're talking about that, right?
Yes, sir.
Okay. Banu, you have any idea?
Not now.
No, okay. So that is known as the longest prefix match, right? This is known as the longest prefix match. So longest prefix match means it is always going to be check, right? Which is the let me write here in the clear way. Longest prefix match, that means whatever the subnet mask we have longer, means 26 is longer than 25. 25 is longer than 24. So if we have the always routing selection process come in a picture, before AD value, they always verify which prefix having the longest subnet mask, longest prefix match. Longest prefix match is going to define which prefix having the highest number of ones in the subnet mask. That's going to be define the longest prefix match. Clear? Means 26 you have the highest number of ones, right? 24 you have the only 24. 25 you have only 25. So always going to check first prefix length. Then if all prefix having the same length, then your AD is going to come with. This is the first, this is second. And then third is going to be different attribute to whatever you're going to do that. This is the normal way to decide the routing. So now again, coming back to the RIV, RIV is going to be collection of the all possible route, right? That is known as the routing information base. And that is going to help you to just create the FIB table, which is the best route. That's a forwarding information base. And that's only going to carry your base route information based on the different path selection methods. It's going to be based on your AD value, longest prefix match, or some other attributes as well. Clear? Are we good till here, guys?
Yes, sir. There is an example I would like to share.
Yes, please go ahead.
For example, we have a destination. So there are like 3 destinations in the map to reach our. There are 3 routes or 3 destinations to reach our destination. So one is the first one is you are only given the street address. Okay, you want to go there, so go to this street. The second one is, okay, you want to go there, then this street and this building. And the third one is completely written like this street, this building, and this floor. So which one you will choose? You will definitely go with the last one because it is giving you the street, the building, and also the floor where your destination is.
Right. That's a very good analogy, right? So that's why, right? Yeah. Thank you so much, Jason, for sharing this. Good analogy. All right, so guys, I believe we are good for a start. Tomorrow, no, tomorrow actually there is the festival in India, and there is a very festive month this time we have in India. So probably tomorrow is the Karwa Chauth, one of the festival. Then we have the Diwali, some other festivals also. So there will be a little bit slightly disconnection in the class, but probably we'll try to accommodate more. So not tomorrow we'll connect. We'll connect. Tomorrow is Friday, right? It's Friday
Yes.
tomorrow. Oh,
Yes.
okay.
Yes,
Okay.
sir.
So probably we can resume on the Monday. So meanwhile, just recap, right? Rev and Fib, because it's a very fundamental things. Try to build this lab. I'm giving the homework as well. Before you coming to the next class, from my side, everyone do this lab as your homework. So at least your routing fundamental is going to be. There is one loop back. /32. There is another loop back. /32. Okay, take any network here. Might be 10 network, 20 network, 30 network, 40 network, 50 network, whatever. Just make the reachability between these point to point. But you have to make sure this should be ping from here and this should ping from here. Means ping 7.7.7.7 with source 1.1.1.1 and ping without source means just ping without source. So it will take the exit interfaces. So this is the one lab. Similarly, different direction you have to ping 1.1.1.1 with source 7.7.7.7. This is the one, and second ping without source. So you make sure you check if do you guys have the packet tracers? No?
Yes, sir.
GNS3. Try to do that. Definitely you guys will get lab from my side also. We'll give the lab, but lab is going to get it on the weekends or might be after this class tomorrow. So try to build this lab, okay? And this is the purely via the static routing, okay? So at least you will understand how complex it is and how the hop by hop routing need to be defined. And then definitely we are going to do the dynamic routing configuration. Even in my lab also, if I just quickly show you, when I start the lab, let me yeah, so we do some basic lab, right? Static EIGRP. So how we can ping the loopback address and all. So I will show you definitely in next class how the static routing is going to run, because this is a basic foundation, and then we'll do the EIGRP. This is the first topic for the EIGRP, and we'll understand the different kind of the routing protocol configurations, tagging, filtering. This all will cover. Don't worry, everything will cover. But that's going to be classic mode, named mode, EIGRP, VRF, global, how it is going to be done in the all kind of the situation for the EIGRP configuration. What is the FD? What is the RD? What is the FC? What is the successor? What is the feasible success? What is the stuck connect tape? What is the stub router? That definitely will do that. And parallelly, we will see while doing the all protocol how we can do the attributes, net route filtering, tagging, distribute list, access list configuration, prefix list configuration. Also, how we can do the summarization without summarizations, and administrative distance, how we can manipulate if we want. That we all see that while doing these all labs. Okay, guys, good for today.
I have one question, sir. There is a part of AAA. So I heard like for Cisco, we need Cisco Identity Service Engine to do the AAA configurations. So how will we do troubleshooting without it?
So AAA basically for we do not have the IEs right now. Okay. I will explain if you want to know AAA settings. I will definitely explain each and everything, how the configuration is going to happen, and how basically we can troubleshoot that situation if it is coming. But we cannot do the live testing because we require the for the AAA for testing. Okay, Jishan?
Okay, sir. Thank you.
Okay, but if you have any lab, means if you have any production environment you want to share that, I can help you out how it is going to happen. But for lab, it looks difficult for us, okay, to just replicate the AAA.
Okay, I have actually experience with AAA. So in case you add it sometime later, so I would love to play a little
Definitely,
bit with it.
I'll leverage your skill set. Okay, don't worry. Okay,
Thank
so
you.
we will try to onboard this AAA also. Okay, thank you, Jishan. Thank you so
Thank,
much.
thank you,
Thank
sir.
you.
And for tomorrow, have a
Tomorrow we
joyful
have the we
troubleshooting.
have one of the festival in India. Okay, so I need to go out with the family. Okay, so this timing I need to be out, so I cannot continue.
Yeah,
Uh,
no problem, sir. Have a nice Karva Chauth.
yeah, thank you so much, Jishan. Thank you so much. Yeah,
Enjoy.
Thank you, sir.
thank
Good
you.
night.
Thank you.
Have a
Thank
nice
you, sir.
evening. Bye.